Hello students, in this session we shall solve few questions from NCERT exemplar. To begin with, we'll solve the questions from exercise 2.1. Choose the correct answer from the given 4 options in the following questions. First one, if one of the zero of the quadratic polynomial k minus 1 times of x square plus kx plus 1 is minus 3, then the value of k is. They have given that one of the zero is minus 3. So it means that p of minus 3 equal to 0. What if p of minus 3 is 0? We need to substitute x value as minus 3. We will be getting k minus 1 time of minus 3 square plus k times of minus 3 plus 1 equal to 0. Simplify this. K minus 1 time of this minus 3 square is 9. Therefore, it becomes 9k minus 9 minus 3k plus 1 equal to 0. 9k minus 3k is 6k. Minus 9 plus 1 is 8 and it is minus 8. When you transpose this minus 8, we get it as plus 8. So the value of k is 8 upon 6. Further, if you simplify 2 4 times, 2 3 times, 4 by 3. So the right answer is option A, 4 by 3. Look at the second one. A quadratic polynomial whose zeros are minus 3 and 4 is. We have to find out the quadratic polynomial now. We have learnt in our discussion in previous sessions that any quadratic polynomial will be of this form. Something like k times of x minus alpha multiplied to x minus beta, where alpha and beta are the zeros. Here alpha you can take as minus 3, beta you can take it as plus 4. We will be getting k times of x plus 3 because the alpha value is minus 3 times x minus 4. Further you multiply, we will be getting k times x square minus x minus 12. Do we have this option? Is it there? X square minus x plus 12 is not there. Second one is x square plus x, it's not there. What about the third one? Is option C correct? For that, let me write this as 2 by 2 times x square minus x minus 12. So I'll get 2 times of x square by 2 minus x minus 6. K value is 2. So this particular expression is there in option C. So option C is the right answer. Here is a trick. I have written k value as 2 by 2, then I have taken this 1 by 2 inside. So we get the expression as x square by 2 minus x by 2 minus 6. Look at the third question. If the zeros of the quadratic polynomial x square plus a plus 1 times of x plus b are 2 and minus 3, then A and B values are. In this case, we need to find out the value of A and B. How do we find that? Let us work out this third question here. They are given that 2 and minus 3 are zeros. It means that P of 2 will be 0 and P of minus 3 will be 0. The given polynomial is P of x square plus a plus 1 time of x plus b. Let us substitute the value of x as 2 and equate it to 0. We will be getting 2 square, which is 4, plus a plus 1 time of 2 plus b equal to 0. So 4 plus 2a plus 2 plus b equal to 0. So 2a plus b equal to minus 6. This 2 plus 4, it becomes 6. So when transposing, it becomes minus 6. So this is our first equation. Let me call this as equation number 1. Similar way, we will substitute the value of x as minus 3 and equate it to 0. On substitution, minus 3 square becomes 9 plus a plus 1 time of minus 3 plus b equal to 0. So this is 9 minus 3a minus 3 plus b equal to 0. Look at this. 9 minus 3 is positive 6. When I transpose this, it becomes negative 6. So the equation will be minus 3a plus b equal to minus 6. This is our equation 2. Now if you subtract equation 2 from equation 1, that is, when you do this, equation 1 minus equation 2, we get b getting cancelled. A plus 3a becomes 5a, which is equal to 0. So a value is 0. If a value is 0, find the value of b. So b becomes minus 6 minus 2 times of 0. So b value is minus 6. So where is the option for a is equal to 0 and b is equal to minus 6? It's in option D. So the right answer is option D. Observe the fourth question. The number of polynomials having zeros minus 2 and 5 is. They have given the zeros of polynomial. This polynomial has to be a quadratic polynomial. So in general, let me write it here. It is in general k times of x plus 2 multiplied to x minus 5. So k times of will be having x square minus 3x minus 10. This is a general form of a polynomial for which the zeros are minus 2 and plus 5. If you consider the value of k as 3, it becomes 3 times of x square minus 3x minus 10. So it is 3x square minus 9x minus 30. Same way, if you take the value of value of k as 5, we will be having 5 multiplied to x square minus 3x minus 10. So 5x square minus 15x minus 50. So we can have more than 3 polynomials having the same zeros. It all depends on the value of k. Fifth question, given that one of the zeros of the cubic polynomial ax cube plus bx square plus cx plus b is 0, one of the zeros is 0, the product of the other two zeros is, since it is a cubic polynomial, if alpha, beta and gamma are zeros, according to the question, one of the zeros is 0. Let me take gamma to be 0. We have learned in our previous discussion, whenever we take the sum of the product of two zeros at a time, alpha beta plus beta gamma plus alpha gamma, which will be C by A since alpha value and beta values are not 0 and gamma value is 0, substitute it, alpha beta plus beta times 0 plus alpha times 0 is C by A. So alpha beta will get it as C by A. So the product of other two zeros is C by A. Option B is right. Now look at question 6. If one of the zeros of the cubic polynomial is minus 1, then the product of other two zeros is, we have to follow the similar method what we had applied in the previous question. One of the zero, let alpha, beta and gamma are zeros. Let me take gamma value as minus 1. Let me take this. We all have learned alpha beta plus beta gamma plus alpha gamma is coefficient of x upon coefficient of x cube. In this question, since gamma value is 1, I'll substitute it here. What is the coefficient of x? The coefficient of x is b. They are given a and b values here, so that you'll get little confused. So we'll consider coefficient of x, which is b, upon coefficient of x cube. Coefficient of x cube is 1. Sorry, I made a mistake here. Gamma value is minus 1. So I have to take this as minus 1. This also is minus 1. So on simplification, we get alpha beta minus beta minus alpha, which is equal to b. The same as alpha beta minus of alpha plus beta, which is equal to b. Remember, we had this alpha plus beta plus gamma. The sum of zeros is coefficient minus of coefficient of x square by coefficient of x cube. So alpha plus beta plus gamma is, what is the coefficient of x square minus a, we have to take them, by coefficient of x cube, coefficient of x cube is 1. So instead of alpha plus beta, we have minus a minus gamma. Since gamma value is minus 1, alpha plus beta will be minus a. This minus 1, when you transpose, it becomes plus 1. Nothing but 1 minus a. Therefore, when we look at this expression, product of the zeros, alpha beta will be b plus alpha plus beta, which is 1 minus a. Where do we have this expression? Positive b, negative a and positive 1 is there in option A. So the right answer is option A. It's little complicated compared to the previous one because the A and B, C values, they are not in their positions of the actual polynomial, standard polynomial. This question is little confusing. Still, when you work out by taking the standard definition, you will be able to get the right answer. Have a look at question 7. The zeros of the quadratic polynomial x square plus 99x plus 127 are. Option A both positive, option B both negative, option C one positive and one negative, option D both equal. Look at all the terms. All these terms are positive. All terms are positive. So it means that the roots or the zeros has to be negative. So option B is the right answer. Both the zeros of this quadratic polynomial will be negative. Now, 8th question. The zeros of the quadratic polynomial x square plus kx plus k is where k not equal to 0. Option A cannot both be positive. Option B cannot both be negative. Option C always unequal. Option D always equal. Let's first understand what is the meaning of k not equal to 0. This k not equal to 0 refers to either k value is greater than 0 or the k value is less than 0. Suppose k value is greater than 0, then what will be the sum of the roots alpha plus beta? It is minus b by a. In this case, b value is k, so minus k by a value is 1, so it is minus k. We have the negative value. What about the product? Product is c by a, which is k by 1, positive value. This particular thing is not possible if alpha and beta greater than 0. This is the first case. Now look at the second case. If k value is less than 0, if k value is less than 0, if you take alpha plus beta, which is minus k, it becomes a positive value. Alpha beta, which is k, it becomes a negative value. Again, this is not possible if alpha and beta greater than 0. Therefore, option A is the right answer. Cannot both be positive. We have seen one of them is negative, another will be positive. Have a look at question 9. If the zeros of the quadratic polynomial ax square plus bx plus c where c not equal to 0 are equal, then option A, c and a have positive signs. Option B, c and b have positive signs. Opposite signs, not positive, opposite signs. C and A have the same sign. C and B have the same sign. According to the statement, the zeros of the polynomial is equal. Let me work out here. Let zeros be alpha and alpha, since they are equal roots. Sum of the roots is minus b by a, which implies 2 times alpha is minus b by a, which implies alpha is minus b by 2a. Let me call this as equation 1. Product of the roots alpha into beta is c by a. Since beta and alpha they are same, equal roots, so alpha into alpha will be c by a because the roots are equal. So alpha square we get it as c by a. From equation 1 we can substitute the value of alpha as minus b by 2a. So minus b by 2a whole square equal to c by a. Now when you square this, we get it as b square upon 4a square, which is equal to c by a. What will be b square from this equation? It will be c times of 4a square divided by a. The reason is a is not equal to 0, we can cancel because we know the standard form of polynomial. The coefficient of x square is not always 0, it cannot be 0. So b square we get it as 4ac. Since 4ac is greater than 0, which means that c and a both are positive, or c and a both are negative. Therefore, option C is the right answer. C and A have same sign. If this is true, then A and C either they must be positive or they must be negative. Both should have same sign. Look at the 10th question. Suppose if I consider for a quadratic polynomial alpha and beta are the two roots. Beta I'll take as minus alpha. The reason is one of the negative is one of the root is a negative of the other. So alpha and minus alpha are the roots. Suppose if I consider the sum is alpha plus minus alpha, which is equal to coefficient of x by coefficient of x square. So I will write as minus a by 1 alpha plus minus alpha is 0. 0 is equal to minus a, therefore a will be 0. If a is equal to 0, look at the polynomial x square plus ax plus b. If a is 0, it becomes x square plus b. Sorry, it is x square plus b. So x square will plus b will be the polynomial. Therefore, it has no linear term. And you just observe the product of the roots. It's alpha into minus alpha, which is equal to constant term divided by the coefficient of x square. Therefore, minus alpha square equal to b. So alpha square is minus b. In other words, b value is minus alpha square, which means the constant term is negative. Since the constant term is negative and there is no linear term, we have to search in each of the options. Look at the options. Option A, it has got no linear term and the constant term is negative. Option B, it has no linear term and constant term is positive. Option C is linear term and constant term is negative. Option A is suitable. Therefore, the right answer is option A. In none of the other options, we have got not a linear term and constant term is negative. It is there only in option A. Therefore, option A is the right answer for the 10th question. Look at question number 11. Which of the following is not a graph of a quadratic polynomial? We have learned in our previous session, the graph of a quadratic polynomial will always be a parabola. Here there are 3 graphs having parabola. The number of zeros can be 0, the number of zeros can be 1. At the most, the number of zeros is 2 for a quadratic polynomial. In the first, second and third, we have these options: 0 number of zeros, 1 0 and 2 zeros, whereas in option D we have got a curve passing through x-axis at 3 different points. Therefore, it is not possible for a quadratic polynomial. Therefore, option D is the one which is not having a quadratic polynomial. Further, in our next session, we shall discuss exercise 2.2 onwards.